Hello, Algebra 1 students. This video is for those of you who are still struggling a little bit with finding domain and range from a graph. And specifically, there was an assignment we completed last week that was just called Domain and Range. It was a worksheet, and it was all about finding domain and range on a graph. One side was domain and range 1, and then there was domain and range 2 on the other side. And probably the side that says domain and range 1 was the harder of the two, because those graphs had arrows on them, meaning they continued past where you could see them on the graph. It was a little more abstract than the other side where you were just naming the endpoints. So I'm going to do a couple of examples here that will hopefully give you an idea of what the questions are asking. So let's suppose you're looking at a graph and it looks something like, I don't know this. And I ask you for the domain and the range. Well, what domain is really asking you, when I ask you what the domain is, I am saying what values of x are covered by this graph. Meaning along the x-axis, are there any places where the graph does not touch? And it probably is easier to ask yourself, are there any places where the graph does not cover? Because most graphs cover a lot of space on these axes. So here's what I want you to think about. This is the x-axis here. And so I want to know, are there any numbers along that x-axis that this graph here is not going to touch? And so what you can do is go as far out to the right as you can think of and imagine a vertical line. I did this with a pen in class, but imagine a vertical line here, and imagine I extended this graph down as far as it could go. Imagine this line went for infinity. Okay, so this line extends past just the screen. It keeps going forever and ever and ever and ever. And this line keeps going forever and ever and ever and ever. Is this graph eventually going to hit this line? And hopefully you can see, because it is sloped out to the right a little bit, that it would eventually hit a line if I had a line drawn over here. So this graph is never going to stop. There's never going to be any place along this x-axis where that graph is not going to eventually hit. Okay? So it goes forever this way. Let's do the same thing on the left, and I drew this kind of badly. This should slope outwards just a little bit. But again, if I were to draw a vertical line here, okay, along the x-axis, but if I were to find a spot and say, okay, I want to look right here, is that graph eventually going to hit? Yes, you should see that it does. And again, I didn't mean to draw that quite so vertical, but it should slope out a little ways. And if it does hit, that means there's no limitations. So this graph is going to cover everything in this direction. It's going to cover everything in this direction. And there aren't any gaps in the graph in between. There aren't any holes. So for this one, for my domain, I'm going to say all real numbers. Okay, that's the official way to say this graph never ends. Then let's do the same thing going up and down. So the range is talking about y values. So if I go way up to the top of this axis and draw a line here, is this graph eventually going to hit where I have that line going? And if you extended this, then yes, it would. And then same thing down here on the bottom. If I were to draw a line down here, is my graph eventually going to hit that line? Yes, it will. So again, and because I don't have any holes in between, this one, the range would also be all real numbers. Okay, so let's look at one where that weren't necessarily true. Okay, so this time I'm going to have this be my graph. And because the graph would have to tell you what this low point was, I'm going to tell you that this graph is at 0, -3. And I want domain and range. So, again, and this time I'll actually draw the line so you can maybe get a better visual. If I were to draw a line way out here, would my graph eventually hit it? And again, we're pretending this line goes up forever or down forever. And if we were to extend this graph, eventually it would run into that pink line over there on the left. Okay, so there's nothing here along the x-axis. There's no number, if I were to continue out this way, where that graph would not eventually touch. Let's look at the other direction. Let's look over here. Okay, if I were to draw a line out here, and I were to extend this graph up, again, pretending both of these lines went forever. And again, this graph is sort of sloping outward. Okay, it's not truly vertical, even if it looks like it's drawn that way. So it is eventually going to hit that. So it's going to hit everything beyond the graph. And there's nothing in between, there's no spaces along the graph that it doesn't hit. So I would say that my domain, all real numbers. But now let's talk about the range. Okay, for the range, I'm looking at up and down. And up is no problem, right? If I were to draw a line up here, these arrows are eventually going to hit that red line. But down here, notice the graph is never going to hit that because the graph stops. Okay, it has a stopping point. And so what we want to say is that the very lowest this graph is ever going to get is this number right here on the y-axis. And on the y-axis, the way I have this labeled, that's a -3. So I want to somehow say it's going to hit everything starting at -3 and heading upward. And so to say that, I would say all real numbers that are greater than, because it's above, or equal, because it does actually hit -3. -3. Okay, so domain would be all reals, range would be all reals greater than or equal to -3. There's one other weird one. Well, there's a lot of weird ones you might see, but just one other issue that I wanted to point out. Let's say you have a graph that looks like this. Again, my drawing is not great because drawing on this thing is kind of tough, and I want the domain and range. Now on this one, for the domain, to the right is no problem because this arrow is eventually going to hit everything. Okay, this arrow is going to go forever and ever and ever, and we're not going to have to worry about it. And then same thing here on the left. Okay, it's going to go forever and ever and ever and hit everything. But do you see that as I follow this graph, that there's a gap from here to here? There's a space here. And so what I want to know is along the x-axis, where is that space located? Let me kind of color in that space for you a little bit. This is the space I'm talking about. And I want to know along the x-axis what number does that represent. And hopefully you see that right there in the center, that's 0. So I hit everything positive and I hit everything negative. I just don't hit this number right in the middle, which happens to be 0. So I'm going to say my domain is all reals except 0. Sorry, I couldn't quite fit that in, but all reals except 0, and that's what that not equal to sign means. That means this graph hits every single x value except for the number in the middle. Okay, now let's talk about range, because we've kind of got the same thing going on with range. Okay, up is no problem. If I were to draw a line up here, my graph is going to hit it for sure, no matter how high I make it. But down here, my graph is not going to hit. Okay, and in fact, it doesn't even hit this x-axis. What's going to happen here, and I know we haven't studied these graphs yet, but this graph is going to get closer and closer and closer to the x-axis without actually touching it. Okay, it's going to get super, super close on both sides, but it's never going to touch it and it's never going to cross it. That's called having an asymptote. So we want to say it hits everything that's above whatever number this represents on the y-axis. So again, this is like my space. And if I were counting along the y-axis, and I counted down and I got right here, that is also 0. Okay? So we want to say that it stays above 0, but this time it doesn't actually hit 0. Oh, that's a 0. Doesn't actually hit 0, so notice I'm not putting an equal sign down here. Okay? I'm saying it's everything above 0. Okay, hopefully those examples will make some sense. If not, feel free to come see me next week and I can help you out with that too.